Thank you very much. And I also would like to express my appreciation for being down here in Rio. Back in Chicago, it's below freezing. We have 6 inches of snow. Very happy to be here. So today I want to talk to you a little bit about the resistance management evaluations that were done in Brazil on Spinosad. And this is just to set things straight. This is a example of the mode of action of different products that are used in agriculture and public health in Brazil, and also some of the resistance factors with OPs and pyrethroids and KDR. And today, as Peter said, in the last 2 days, we've learned a lot about resistance management. And this is just a general slide that shows the mechanisms of resistance that we've seen around the world. And this is an example of what we see in Brazil, just to set the stage. A lot of folks don't realize the amount of work in resistance management that occurs here in Brazil. And I think it's really important that we try to bring that out. And so this presentation will kind of cover that while we talk about it as Spinosad being the example. So from 1999 to 2013, Brazil implemented a program of really intensive resistance monitoring around the country. They utilized 4 laboratories around the country, different geographical locations, and they looked at all the products that are used in public health. They used the testing processes that have been developed by WUPIS over the years. And they worked in conjunction with the vector control programs that are established throughout Brazil, which are quite a few, very large contingent of workers in mosquito control. And finally, an additional responsibility they had was with respect to evaluating new products, new active ingredients that are entering the public health market to see if they truly would be candidates for resistance management to temephos. Spinosad was one of those candidates. So what the organization did, these 4 labs, was choose 4 different populations from around Brazil. And this is an example of the geography of where these 4 populations were chosen from. The investigation involved looking at these 4 populations with established and known resistant profiles and investigate the cross-resistance potential from a total of 9 different populations from throughout Brazil to see if there's any cross-resistance to temephos in these populations, and then try to correlate the results that they found in the lab in the field by conducting a field efficacy study. The laboratory work on the 9 populations throughout Brazil showed that there was no cross-resistance potential between temephos resistant populations and Spinosad. So to correlate this work with the from the lab with the field, the lab that conducted the research utilized the WHO guidelines developed in 2005 for larvicide evaluations. The objectives of this field evaluation was to compare the effect of natural RDT on Aedes aegypti populations with different susceptibility to temephos. And the conditions of the trial were breeding sites were 300-liter plastic containers. Water replacement occurred once a week in 1/3 increments. This is what is established as a standard norm in Brazil, that usually a 200, 300-liter drum is emptied in a week. Local conditions, the water containers were stored in the shade, and that's where most water containers are stored in Brazil, in the shade. Replicates were 2 controls and 4 replicates for each treatment in Aedes aegypti population. And in addition, the entire trial was replicated 3 times during different times of the year to determine if there was any climate factors. The other thing to bring out is that the 300-liter water reservoirs was larger than the label directions for the product. The product is a tablet, and it's recommended for application to 200 liters. So the trial was actually a stress test. Natural RDT, a specific batch that's actually sold in Brazil, was used. This is an example of what the formulation looks like. It's actually a bilayer tablet. Half the tablet contains an effervescent layer that dissolves immediately, killing the larvae that are present in the water at the time of the application. And the other portion of the tablet is a residual, providing 60 days of control. The tablet's scored so they can be split in half to treat smaller containers. Conditions of the trial: the treatment occurred on day 0. Weekly challenges to the containers occurred using 3rd-inch star larvae, total of 30 larvae per container. Mortality was read at 48 hours. The 4 populations that were used had different mechanisms of resistance and different levels of resistance to temephos. This is the resistant ratios that were for each of the populations. Range from a resistance ratio of 3.3 for the Morelia population to 16.7 for the Salvador strain. The reference strain was the Rockefeller. And to further the example, they wanted to make sure that each of the populations that was tested had a different mechanism of resistance. And so this graphic shows the level of separation between the 4 populations and the characterization of resistance. This is a picture of the drums that were used in the trial. And if you look closely, you can see a tube on top of the drums that comes out of the wall, and a tube that is connected by a valve to the drum. And this kind of ensured that the water level, when it was added to the container, is added as water is added in Brazil, and it's withdrawn from the bottom as it is usually done in normal circumstances. The population levels were changed off to ensure there was no bias with the location of the containers in the test site. And the results of the field trial are comparing the reference strain to 2 of the populations, Morelia in Salvador. In this in graphic, the red is the Salvador population, the blue is the Morelia, and the green is the reference. And mortality for natural RDT, the spinosad-based larvicide, was over 80% for the entire 8-week period. Same's true for the other 2 population levels. The sanitarium was gray, the goenia was blue, and the reference strain again was green. Again, with these 2 resistant, temephos-resistant populations, spinosad provided over 80% control for the entire 8-week period. Conclusions of the trial are that under the conditions described, natural RDT presented residual activity above 80% mortality for the 5 Aedes aegypti populations: the reference strain, Rockefeller, the Morelia strain located in Sao Paulo, the Goiânia strain located in Goiás, the Sanitarium strain located in Para, and the Salvador strain located in Bahia for the 8-week period. And there was no significant differences on residual effect of natural RDT treatment among the Aedes aegypti populations, regardless of their different profile susceptibility to temephos. The result of this laboratory and field evaluation is that natural RDT, a spinosad-based larvicide, could be considered a management tool in organophosphate-resistant Aedes aegypti management programs in Brazil. The follow-through was that the federal government added spinosad-based larvicides to the list of products approved for use in Brazil for resistance management.